Hello, Algebra Tours. Welcome to the last week that we need to learn. I'm so excited for you. After we get through this week, we'll be done with distance learning, okay? As much as we've all loved it. I'm excited. I know you're excited. Let's get through it. Hopefully I get to see your faces very soon, but let's get started with this because let's make it short so you can watch the video, get what you need to get, and move on with our lives for this year, okay? So logs, the solving equations that contain a log. So this is really what we've been trying to get to with all of this log stuff. So you want to get your notes out. You're definitely going to need a calculator. You might not have to use that online calculator we talked about, but you are going to understand where we were going with all of this stuff. So again, get your calculator out, need to take a notes, definitely something to write with, and let's see what it's all about. So for starters, how do I solve an equation that has a log in it? Before we'd have logs that have two numbers here, but now we have an equation here that has an x inside my log. So how am I going to get rid of, or how am I going to get this x out of here? How do I solve with that x in here? That's the question of the day. We're going to have to go back and we're going to have to remember the converting lesson that we talked about. So making sure that we figure out what this actually means, what this tells us, to help us figure out and solve that. So you're going to find out that we're actually going to try and convert these to exponential equations to help us solve, because if I convert it, it gets rid of the log. I take 2 to the 6 equaling x. Well, now x is standing all alone and I can solve. Okay, it makes more sense when I convert it back out of logs for me to understand what that means. So we've converted to we've converted from exponential to logs. Now we're converting from logs to exponential. We did this a little bit in our converting video, but haven't really used it since. Here's when we're going to use it. Okay, so just keep that in mind. We're going from logs to exponential. Okay, so let's see how this looks when we're trying to actually solve a log equation. Before we get started here, we got to know a couple things because we're going to have to check to make sure that they actually work. These solutions that we get have to actually work. So when in this form, the a value, this a in here, has to be greater than 0. What that means is you cannot have negatives inside log functions. Okay, this is important. If you ever see a negative in here, if we're ever trying to plug in a negative inside of this log function, you will know that it is an extraneous solution. So maybe something you want to write down in your notes. Negative values inside of the logs equals extraneous solution. Okay, so that means if I ever get a negative value for this a in here, I can definitely right off the bat say it's extraneous. Okay, you cannot have negative numbers inside of your log. Another thing to note, if a is 0, that also means no solution or extraneous solution. Okay, so we know that a has to be greater than 0. It cannot equal or be less than 0. Okay, moral of the story, no negatives, no zeros. Okay, jot that down. That's a really, really big thing. All right, so our first example of the day here, log base 5 of the quantity 4x minus 7 equals log base 5 of the quantity x plus 5. Notice we have logs on both sides. There's nothing else but the 2 logs on each side of this equal sign. So just like when we found the same base, when you were raising that exponent and they on both sides had the same base, we just dropped the base. Likewise, when they have the same log on both sides, we're just going to drop the logs. So I would get 4x minus 7 equals x plus 5. And this just becomes an algebraic problem for me to use my algebra skills and solve. Subtract x from both sides, 3x, add 7 to both sides, equals 12. So x equals 4. So the answer I get back is x equals 4. Now I just need to make sure that it's a good solution, so I got to take this and plug it in. The only thing I can't get is negatives or 0. So 4 times 4, if I were to plug in a 4 here, 4 times 4 would be 16 minus 7 would be 9. Positive number, that works. Double check this other side. 4 plus 5, None. Positive number, we're good. In this instance, since we have logs on both sides, they should be the same number, which they ended up being the same number. But again, as long as they're not negatives or zeros, you should get a good solid answer. We know 4 works. On to the next example. All right, now example number 2, we have log base 2 of the quantity x minus 4 equaling 3. This one's a little different. I can't just drop the log because it's not on both sides. But like I've mentioned a little bit, we have this tool in our pocket where we could maybe convert this log to an exponential equation to help us solve. Okay, so we might have to use that converting tool that I have to help me figure this out. I got to get that x minus 4 standing alone, which essentially will help me to get the x standing alone. That's what it means to solve for x. Isolate the x. Well, right now, since it's in the log, I can't do that. So let's convert it. Let's change it completely. Okay, so let's take it to exponential. And again, with the exponential, we make that e. So I come all the way around and then back down. So I get 2 raised to the third equals x minus 4. By converting it to exponential form, I get rid of that log entirely. I can't use the log and calculate the number because there's an x inside my log. It has to be both numbers in order to calculate the log and what it gets back. So now I get 2 raised to the third, which is just a number. If we type that into our calculator, or if we could know that off the top of our head, that's just the value 8. So 8 equals x minus 4. Again, this is just an algebraic problem for us to solve. We add 4 to both sides, and I get back x equals 12. So now let's double check, is this a good solution? That means I need to plug it back into my equation. 12 minus 4 is 8. So log base 2 of 8, that should work. You could type that into your calculator. Log base 2 of 8 equals 3. You could type this into your calculator, and the number you'd get back is 3. So it will tell you that 3 equals 3. You could do that, but I promise you, as long as you're getting a positive number over here, it's going to work. So I can save you a little bit of time, okay? So the checking your work again, that's just to make sure that this answer you found over here is correct. If you get a positive answer, the log itself works. The checking it to see that it works, it does equal 3. That's just making sure that you did this math over here correct, okay? So again, making sure that it's not 0 or negative, make sure it's a good solution. If you want to check your work like this, that's telling you that the math you did over here is actually correct. Okay, if this ends up not working, that means you did something wrong over here. But again, you don't have to take this step if you don't want to. It's only for those of you that want to make sure you're actually correct. So like I said, make sure that it's not 0 or negative, and you should be golden. Now, how's example 3 maybe a little different from example 1 and 2? Well, it looks like I don't have 2 logs. I don't have a log on each side, okay? But in order to use what I did in example 2, the log has to be standing alone. So if this ever happens where the log, you only have 1 log, you got to make sure it's standing alone before you can convert it. So in order to do that, I need to get rid of this 7 here. So I'm going to subtract 7 from both sides. So I get log base 10 of x equals negative 3. Now notice it's negative, but it's way over here. It's not involved inside my log, so far we're good. Now I have to convert in order to figure out what x is, because x is right now inside my log. So let's convert. Change it to an e. I get 10 raised to the negative third equals x. Well, x is already alone, so I just got to figure out what this means. Hopefully you remember that this negative means that it's going to throw that to the bottom. So we get 1 over 10 to the third, which equals x. X equals 1 over 1,000. Okay, so you want to double check that that works. Throw it in here. When you throw it in, it's positive, even though it's a really, really small number. It's positive, so this should work. I could type it into my calculator if I really wanted to, but like I said, as long as it's positive, I trust my math is correct down here, and so I found a good answer. Okay, so again, making sure the log is isolated. If it's not isolated, you just have to get it isolated before you can convert it. So if you have any questions, make sure you're writing them down as we go. All right, our last example then in the video here, notice I have 2 logs. So this kind of relates to the first one, but the 2 logs I have are on the same side. So we're going to have to use our expanding and condensing rules to help us figure out and condense this into 1 log, so then I can convert and solve from there. Okay, so notice since I have the plus sign here, if I were to condense, plus means to multiply. So if I wanted to make one log out of this, since they both have the same base here, all I would have to do is take x times x plus 12 on the inside. Okay, because again, when I condense, the plus here means multiply. This all equals 3. Again, I couldn't just drop the logs because they're on the same side. The only time I can drop the logs is if there's an equal sign between them and there's only logs on each side. Okay, so since I have the logs on the same side combined by a plus sign, this means I'm using my expanding and condensing. So I'm going to condense here. So I'm going to get log of 4, log base 4 of, then I'm going to get x squared because I'm going to have to distribute this x squared plus 12x. And again, this all equals 3. So now, just like examples 2 and 3, we're going to have to convert this because I have the x on the inside of my log. So I'm going to have to take this and convert it to an exponential equation. So start with my base, go all the way around, come back through. Looks like I'm going to get 4 raised to the third equals x squared plus 12x. And I'm sure a lot of you are already like, oh boy, here we go. Because since I have an x squared and an x, I hope your brain throws up a red flag and says, we're going to have to factor. As much as we all love it, we're going to have to do it because there's an x squared and an x. Okay, so let's convert this 4 to the third to a number. 4 raised to the third is 64, I do believe. Let me double check on my calculator. 4 raised to the third. Yep, 64. Equaling x squared plus 12x. Now, we're going to have to get it equal to 0, so I'm going to have to subtract 64 over here. I get 0 equals x squared plus 12x minus 64. Well, that's good that it's minus because then over here I can figure out easier what 12 is. So again, factoring, let's make 2 sets of parentheses. I'm going to bring this work up here. 2 sets of parentheses. I need to get an x squared, so I know that it's going to be x and x. Now I have to go through factors of a negative 64 that when combined would give me 12. So 64 would be, okay, we could do negative 2 and 32. We could switch it around. We could do negative 4 and 16, which when you add those together, hopefully you do see that it is going to come out to be a positive 12. So again, go through all those lists, find the ones that work. I get negative 4 and a positive 16. I'm not quite done yet. Looks like I'm going to get 2 x answers, which is awesome because I was squaring here originally. X is going to equal 4 and x equals a negative 16. Again, you finished your factoring, but we need to go all the way back to the beginning and plug in to make sure that they work. If I plug in a 4 here and a 4 here, I'd get 4 and 16. Both are positive. I'm going to assume that they work. Okay? If I take the negative 16, I get a negative 16 here, and I get a negative 4 here. In both instances, I have a negative inside of my log, so I'm going to assume that negative 16 does not work. Again, you could type it into your calculator to figure out that it wouldn't work. You'd get back an error, but since it's negative, I automatically know it's no solution. With the 4, you could have plugged it into your calculator to find out that it would equal 3, but like I said, as long as it's positive and you trust the work that you did at the bottom, you should be golden. Okay, so in this instance, even though I did get back 2 solutions, only one of them worked. So it would be very important for you to note that, so that way when you are doing your worksheet, you understand that there are solutions that don't work. Okay, so I want to thank you for taking really, really good notes. If you are still listening to me at this point, let's do something a little bit fun. Okay, if you are still listening and you email me, if you're one of the first 3 people to watch the video and the first 3 people to email me, email me the words purple elephant. Okay, if you email me the words purple elephant with your address, I will put together a little fun gift for you, a little prize, I guess, for you watching your video, still listening, and like I said, doing it on time. So purple elephant with your address, I will kind of ding dong ditch your house and leave you a little gift in kind of, I guess, honor of you doing what you're supposed to be doing. Okay, I know it's kind of expected of you, but like I said, let's just reward you a little bit. So, purple elephant, address, first 3 people. I will ding dong ditch your house, leave you a little gift with a note from me to reward you for watching your video. Okay, so you don't have to if you don't want to, but like I said, if you would like to, email me, purple elephant, with your address. I will deliver you a gift sometime this week. Okay, so again, thanks for taking good notes. I hope to see you so soon. Talk to you later. Kessler out.